Just trying to see how this thing works because it obviously has quirks. So, is the PowerPoint going to be loaded? Okay, well, we'll wait just a second until the PowerPoint shows up. We'll go backwards and start doing performance-based. Should I sing? The answer you ought to know is no. No, she should not. Yeah? Oh, no, nope, that's the last one. So we went the one that says Dixon. So I guess while we're waiting, I'll tell you all that, oh, here we go. The Highway Safety Manual took us 10 years to develop the first edition of the Highway Safety Manual. We kept on saying 6 years, then 7 years, then 8 years, and it just slid into 10. And then as soon as we got it published, we were talking to AASHTO, and they said, well, we need to be thinking about the second edition of the Highway Safety Manual because we recognized that this was a new document, the first of its kind, and certainly there were going to be gaps. We actually had to make gaps because we had to get something out there, and so we tried to tackle the things that needed the most consideration first. So when we finished the edition, we were all exhausted. We had our first meeting afterwards, and we patting ourselves on the back saying, well, at least it's done. You know, now we got to go and figure out what kind of errors we have, what kind of deployment issues we're going to have. And AASHTO said, you need to start thinking about the second edition because we want to publish it in 4 years. So I don't know if y'all have noticed, but this is 2015. There is no Highway Safety Manual yet. We think it's going to take us about 10 more years. It's a lot of new information that we're adding. So what I want to do today is talk a little bit about the first edition of the Highway Safety Manual, some of the issues we've noticed in trying to apply the Highway Safety Manual and some of the applications that seems to be the most popular for it, and then just a little hint about what's coming. So when we came up with the Highway Safety Manual, we recognized that the Highway Capacity Manual has this really important role that it's had for years and years and years to try and help us better understand how our facilities operate. And we thought that it was just common sense that we needed to have something like that that would do the same thing for us. But the thing that we noticed with the Highway Capacity Manual, and when you compared it to how we were doing safety evaluations, and we've been doing safety evaluations of one sort or another for many, many years, was that the Highway Capacity Manual was based on data. And if two people did a calculation, and they made the same basic assumptions, which, you know, they could make slightly different assumptions, but they'd be in the same ballpark, they can get about the same answer, and that is not something we have for safety. So our need was to try and have a way to integrate safety into the decision process, but make it in such a way that it was data-driven, empirically based, and reproducible, so that you could justify your decisions. And then, of course, George made a really great comment, which was that we wanted to be part of the party. I know that in the NEPA process, there's always on the matrix a line that says safety, but we wanted it to be a quantifiable, not a subjective evaluation. So we just wanted to make sure that when you're thinking about what you can do, that safety has a place at table setting at the table. We're not on the children's table anymore. Y'all don't do that at Thanksgiving? We also recognize that safety has two dimensions, and before I wandered back into the world of academia, I was an interchange designer, and I felt there's that cricket. And I felt when I was an interchange designer that the Green Book was the gospel. And I still kind of feel that way, to tell you the truth, when it comes to highway design. But I also thought that it would be nice to know a little bit more about where the information in the Green Book comes from and where it's rigid and where it's flexible. And we recognize now that the Green Book gives us what I would call a core value to try and shoot for. But we recognize that sometimes, as we saw in the performance-based presentation, there might be a practicality issue. And I've heard many people say, well, we're not going to build the project because we can't get to that. And if we can't get to that, we don't want to do the project. We don't want to do it halfway. Well, halfway is sure better than no way at all. And so we recognize that that's one of the dimensions, is trying to achieve the Green Book, but a second one is something that we call substantive safety, which is trying to make sure that we're improving safety for the traveling public in whatever way we can. So the Highway Safety Manual focuses on this substantive safety, which is the computational based. And so in the Green Book, as an example, I might have a radius that's got a minimum value of 750 feet. I'm going to try and have 750 feet from my radius, but does that mean that if I have a radius at 749 feet, my road is not safe? Or does it mean that it's maybe less safe than if my road had a radius of 760 feet? And that's what substantive safety is meant to do, is to try and just help us understand those shades of gray and that things aren't just rigid, that they're actually changing. Or in other words, you can see that the Green Book might have that 750 as a yes or a no. Have you met that or not? Whereas the Highway Safety Manual approach would be, okay, we want to meet that, but if we don't, how far off are we? And what's it going to do to safety? So we call that nominal versus substantive safety in the Highway Safety Manual. As I mentioned, the Highway Capacity Manual was kind of the model that we used. We didn't make it look like the Highway Capacity Manual, but we really liked the way that's integrated into our profession. And it's not a mandate, it's a set of tools that someone can use to try and advance forward. And so that's why we really use that as our model, was the Highway Capacity Manual. It's definitive, it's widely used, but the most important one for us was the third one, which is it's science-based, it's data-driven. I might also mention that the science-based and data-driven issue was a point of contention when we were doing the preparation for the Highway Safety Manual. We recognize that there are some things we do not have data for, and it's important to try and address those issues. I'll give you an example of maybe pedestrian and bicycle traffic, or volume, not traffic volume, but pedestrian volume and bicycle volume. We need to know that stuff because obviously that's going to be important to the design. We don't have that information. We had to make the decision that we would try and tackle it on urban and suburban arterial roadways, and that would be the only place we could get it into the first edition of the Highway Safety Manual. Doesn't mean that we're not going to continue looking at it, it just meant that we didn't have that data. Even if we have a method for someone to apply it, who has that kind of data in their database? And so we were trying to think about how can these tools be deployed the best way, and who has that sort of information in their data set. So essentially, we noticed that there were all sorts of project level decisions that you can make, and all we want to do is put the Highway Safety Manual as a continuum that it's not going to be, safety analysis is not going to be a yes or no, it's going to be part of that overall decision process. All right, so this is a graphic that I use a lot, and it's basically to try and represent why I thought the Highway Safety Manual was important. We have these four conditions. One is basically the existing conditions, then you have three candidate alternatives, and we're doing an alternative analysis. We could probably do a level of service analysis on those three alternatives, but before we had the evolving highway safety evaluation tools, if I'd asked you what is the safest alternative, 1, 2, or 3, what would you think? Now you'll notice on 1, it has a continuous left turn lane. It has 2 through lanes, but a really wide sidewalk. Number 2, they've tried to do some access management by putting in a finger island so that they can have a turn, but hopefully you're not going to have as much motion for left turns, though pedestrians could probably go over and use part of that for refuge, not the finger part, but the rest. And they have a transit lane, and the third one, maybe extra lanes and a barrier wall. Which one do you think would have the fewest crashes? All right, it's a quiz. I'm going to go 1. How many 1? How many of you think 2 has the fewest crashes? How many of you think 3 has the fewest crashes? Yeah, the answer, of course, is it depends, but 3 probably has the fewest crashes. But does it fit with the environment that it's in? And is it practical? Is a pedestrian going to be able to get across the street from one side to the other without walking 2 miles out of their way? If the answer to that is the pedestrian needs to cross the road, and it's not practical to do so at this location, then maybe you need to reconsider your evaluation. But historically, we haven't had the ability to do that. So that's the reason that we tried to come up with some flexibility in the way we apply the tools. They're continue to evolve so that you can have alternatives like this and be able to make quantitative decisions. The HSM, how many of you have, first of all, let me ask the question, how many of you have seen or touched a highway safety manual? Oh gosh, we still have work to do. Well, I didn't bring mine, or I would give you the opportunity to both see and touch, but it's 4 volumes. The 2010 release had three volumes in it, and then we had a supplement that just came out that's freeway and interchanges. So we felt like it was important to go ahead and get that out. So we have 4 volumes now. It has the 2010 release had 3 parts because we thought it was going to be, 4 parts. We thought it was going to be 4 volumes then, and so unfortunately for us, when they did the binding, our 4 parts became 3 volumes, which really confused the living daylights out of me. But what I can tell you is that volume number 2 is probably the one that people are most interested in. Volume number 1 tells you a little bit about fundamentals of safety, and it also tells you about how you can incorporate safety into the planning process, a very important topic. Many of the tools in there we've had for years. Many are new tools that have actually come from the analysis that's in Volume 2 of the Highway Safety Manual. Volume 2 is where we actually have new ways to predict safety. And then Volume 3 is a companion of that, which has crash modification factors or functions. I'll talk about what those are in just a sec. So I said Volume 2 has these predictive methods. We call those safety performance functions, or SPFs. And as a general rule, they have nationally derived SPFs that have multiple states. If you're going to use them for your state or your location, it's good to have either one that you've developed for your state and or one that you've calibrated to your state, because you have some local variations. For example, some places they might have a lot of crashes between animals that are running across the road. Does that happen a lot in Houston, downtown Houston, that project we were talking about? Have y'all had a problem with animal hits? No? Probably not. But, you know, it certainly is going to be a problem in Montana. And so they have to do adjustments for that. Or there might be a place where you have, shall I say, the more experienced driver with at least 50 years of driving experience coming there in a seasonal application. And you might want to try and understand what kind of issues you have associated with that particular road user compared to a college town like we have today. Has anyone driven around and enjoyed the driving of the college students? I do enjoy it as long as I'm sitting at the side of the road watching it. But when I'm in a car, it's a little scary sometimes. So, you know, if you have something like that, you need to calibrate these for your local jurisdictions. It's not a complicated process, but it is something that would be a great project for your local university to help you with. That's just a punch to try and get them some research. There's a second method that's called the EB method. We call it EB because it's actually based on something called an empirical Bayes method, and that sounds pretty scary and statistic-y. I don't know if that's a word, but it's scary. The empirical Bayes method is really nothing more than a weighting factor when it's applied to these safety performance functions. You take the crashes that you've predicted, and then if at a very specific site, you take a look at the history of the crashes and you weight them together depending upon how well that equation performs. Sometimes it performs great, sometimes it doesn't perform so great. One of my students and I were working at Oregon State University, and we actually had one case where we had a site that had this overrepresentation of crashes. It didn't fit very well at all with the safety performance function. So when you predict the number of crashes at that location, you see that you probably need to pull the crashes down. You do have to consider, is there something else that's not being accounted for? In this particular case, I went and looked in the evening, because when I did a collision diagram, I saw that the crashes were I would say occurring frequently in one particular direction of travel. So I thought, well, I'm going to go see what's happening in the evening in that direction of travel. And lo and behold, it's the sun setting, and there's another traffic signal just beyond, and there's a railroad track in between. This traffic signal was maintained by the state. The traffic signal you could see beyond was maintained by the city. And both of them separated by the row. And when the sun was going down, you couldn't see the closest signal head. You could only see the further signal head. So people were shooting right into the intersection. They weren't timed together. So that's something that is unique to a site that we actually have to consider. So that shows up in your EB analysis and not in just your general analysis. The other thing I mentioned is called a crash modification factor or function. The only difference between those two is one is just a single number and one is an equation. And I try and think of it as M is for multiply. It's a way to adjust and determine if I make a change. Let's say, for example, I change my lane width from 11 feet to 12 feet. How would that affect the safety? Usually, if a CMF, crash modification factor, is 1.0, that means there is no change whatsoever. If it's greater than 1, then that means you would increase crashes. You multiply something bigger than 1. And if it's less than, then it means you're going to see a decrease in crashes. So your target is to try and find CMFs, countermeasures with CMFs that are less than 1. There's a great resource available for this. It's the Federal Highway Administration's CMF Clearinghouse. Later on, I have a slide that shows its website, but if you just type in CMF Clearinghouse, it actually takes you straight to that site. And it will show you every CMF that they've been able to identify. And it gives you a rating to tell you the quality of the CMFs. The Highway Safety Manual has the third of the 4 editions, the 4 volumes, that actually is all CMFs. That's all it has in there. In the next edition of the Highway Safety Manual, we're exploring right now whether or not it's going to stay in that current format because the Clearinghouse has such a dynamic ability to update CMFs, so we might change the way that it's presented and have it maybe telling you a little bit more about how to use CMFs rather than what CMFs are. This is just an example. If a CMF is 0.9, that tells you that you'd have a 10% decrease in crashes. All right, so just a quick snapshot of how the Highway Safety Manual works. I don't want to go into any of the details, but I can tell you that the equations are not particularly complicated. We try to keep them straightforward. All you have to be able to do is add, subtract, multiply, divide, and if you have a calculator that has e to the power of, that's a bonus. You can probably do every single equation that's in the Highway Safety Manual. Now, my problem is not punching in numbers into the equations. My problem appears to be pulling numbers from tables. I make lots of errors doing that. And so we've also got some tool solutions for you because of that. So the Highway Safety Manual, we already talked a little bit about this, but really the key thing is that we want to have a tool that we know is reliable, science-based, and down at the bottom, the 4th bullet says, does not increase the risk of tort liability. So in the United States, we are protected by federal law if we're actually evaluating a site to try and improve safety. Those calculations could be, if you're willing to disclose them, they could be used against you, but you don't have to disclose them if you're using them for your own benefit to try and improve safety. So we had an attorney that helped us with the Highway Safety Manual. We actually had a couple of attorneys, but one of them then subsequently helped me in preparation with some training materials. And I said, I need a slide on how the Highway Safety Manual will protect us from tort liability. And he gave me a slide on what the Highway Safety Manual is not. Now, I don't know if y'all have ever worked with lawyers before, but apparently this is the standard operating procedure, just to tell what it's not, and then whatever's left over is, I guess, what it is. So I didn't include that, but basically, the goal is the Highway Safety Manual is meant to be a tool that's not going to be used against you. It's going to be used to improve safety, and that's its primary goal, and you can protect yourself because of that. All right, so in the Highway Safety Manual, the term safety is referred to as crashes, and you saw George's example a while ago where he had total crashes, and he also had it broken down by the different severity levels. And we, of course, recognize that historically we've used crash rate, which gives you a good idea about the context. If you can think about the exposure level, then it's an important thing to be considering, so you're comparing apples to apples. But what we've discovered is that crash rate really doesn't answer the questions we've had before, because crash rate was basically the number of crashes divided by some sort of a volume. And that implies that it's kind of the slope of a line. But if we were to plot crashes on a matrix that had volume and number of crashes, what we find is it's not a line at all. Maybe you might have 1 or 2 roads that has parts that are lines, but it's always going to be curvilinear. And so that's the reason we needed to come up with some sort of a different way to do this. So these safety performance functions do predict crashes, but they predict crashes in the context of the traffic volume on the facility. I have had a few people tell me, well, the thing is that crashes can't be predicted. And for years, I've been told that crashes are both random, and they're rare. Have y'all heard that? Crashes are random, and how can you predict something like that? Something that's random and rare. Well, for a random crash, the basic idea for a random crash is I can't go out and stand on the corner and say, all right, now, last year on Wednesday, between 10 and 10:15, there was a crash at this corner. So tomorrow, between 10 and 10:15, there's going to be another crash. Can I do that? If I could, I want to go to Vegas and use my skills for other things, probably not predicting a crash on the corner. But what we can tell you is that traditionally, we've noticed at this location, with these conditions, these characteristics, and these type of drivers, it's likely that there's going to be a crash at this location sometime this year or sometime this month, depending upon how frequently you see those crashes. And we can determine that pattern, and that's what we mean by random. So we can predict random events using statistical procedures. The one that's the more curious one is the rare event. Typically, we can count cars, and you can see that, and crashes, and we can see at the top that this would represent the entire population of crashes. The risk is not too great if you're just driving on the road and there's nothing happening on that road. Probably you're in pretty good shape. You're not going to have the likelihood of a crash, so we can probably safely assume that you're not going to have too many crashes on the location. You might have a few things happen. But now, what happens if you're behind another car and that car is driving a little bit slower? Just the presence of another car, and it's the way it's suggesting your driving behavior, that will increase your risk. What happens if you're driving along this rural location, mountainous location, and a rock falls right in front of you? That's pretty rare, isn't it? But that's even a bigger risk. I actually had one of my students have that happen to him and actually fell on his pickup, by the way. So it's rare, but it will happen. I told him he should never have gone up there to snowboard. He should have been in class, but he didn't listen to me. So we can determine, based on proportional analysis, these rare events too. So between random and rare events, the Highway Safety Manual allows you to do a pretty accurate prediction. The only thing it does not really account for is the fact that we don't know a lot about unspoken for circumstances like the traffic signal sunset issue at that intersection I was mentioning. If you're not familiar with the Catco Scale, I just wanted to briefly be sure that you were aware of that terminology. So the Highway Safety Manual does currently use Catco, though there are other definitions for crashes that are being explored at the national level right now. So K means that it's a crash and it's been reported within 30 days of the crash. A person has been killed, excuse me. A is an incapacitating injury. B is a non-incapacitating, so it's an obvious injury. C is a possible injury. I remember here when I was a student at A&M, my car was hit by a drunk driver. I was driving the car that was hit, and we called the police, and I was standing there talking to the officer, and I guess I went like that. And he wrote, okay, I'm writing down that this is a C. Of course, I had no idea what he was talking about at the time. I said, what do you mean? He said, well, this is a possible injury crash. I said, I don't see anybody that's injured. And he said, I've seen you rub your neck 3 times. That's a possible injury. I thought he was crazy until the next day when I got up out of bed. Could not move my head. O, it means no injuries, so that's the property damage only crash. So historically, we have often looked at this total crash condition, and these really do skew the results. So the Highway Safety Manual includes both the total crashes, which would include PDOs, and also includes just the fatal and injury crashes. An issue about PDOs is also that many jurisdictions report them differently, whereas injury crashes are much more reliably reported. So for example, Oregon is probably the extreme example to this. They will not respond to a crash. The police will not respond to a crash unless someone is injured. So you're required by law to go and tattle on yourself within a certain number of days when you have a crash. And both drivers are supposed to go and file a crash report. And if one does and the other doesn't, then the other one's in trouble. So if you get those crash reports and you compare them, it will say, for example, that I had a crash that was 20 feet from the intersection, and the other driver will say I had a crash and we were 200 feet from the intersection, because those people don't regularly fill out crash reports and they don't have a good sense for it. So that data is not very reliable. By the way, do y'all think that y'all can reliably say 200 versus 20 feet? It's just a problem with even the crash data that we do have for law enforcement officers. So the crash severity is the most extreme of all of those that happened for that particular crash. So if you had a crash with 1 person killed and 2 people injured, it would go down as a K crash. All right, so having set that groundwork, I just want to talk real quick about the available tools, and then I'll wrap up for the Highway Safety Manual. In Volume 1 of the Highway Safety Manual, in the planning process, they have a large number of possible methods that you can use to do safety assessment. They don't have this big arrow on the side that says greater reliability. I just tossed that in because that's what it means. You start at the top, which is average crash frequency or crash rate, the things that we've historically used. And those don't need a lot of data. You need some, but they don't need a lot of data, but they aren't very reliable. And as you go down this table, the more data that you get and the more data-driven the procedure, the more reliable the results. Another way to look at it is, I know that the print is pretty small on this, so I'll just explain real quick what this describes. There are essentially 6 procedures suggested in the Highway Safety Manual for doing analysis. 2 of them are very basic procedures, and so one of them is called perform a relative comparison of CMF analysis. So if you don't even know what the number of crashes are, you can just look at 2 CMFs. Like, I want to maybe widen a lane or widen a shoulder. Which one is going to have the greatest improvement on crashes? So that would be a relative comparison of CMFs. It doesn't need as much data. It's not as reliable, but it still gives you a good sense of what some of the effect could be, because those CMFs were based on some data. The second one would be perform an observed crash frequency using CMF. So basically, you take your CMF, you multiply it times your historic crashes at that site, and say, if everything else stays the same, I can expect to have this number of crashes reduced. There are some issues with that method because typically things don't stay the same. It doesn't account for geometric characteristics or changes over time, but it still is much better than what we used to do. So those are the basic methods. They're probably the methods I see used the most because they're simple, they're intuitive, they don't need a lot of data. And they're still much better than what we historically have been using. The next 2 that I have here both use safety performance functions from the Highway Safety Manual or from locally derived safety performance functions. And they then have to have a little computation with an equation. And then the difference between is one of them adjusts with CMFs and one of them doesn't, depending upon the format of the SPF. So that one, you kind of need to use the Highway Safety Manual. And the third one is also similar. You're going to have the SPFs, but now it uses the EB method. These final 4 look pretty scary. But what we've really been focusing on in the profession is trying to develop tools for the final 4. And we're actually getting tools that are better for those than for the first 2, the easier ones. So I want to just kind of introduce you to those real quick. One of them's already been mentioned, the Interactive Highway Safety Design Module or Manual. Like, actually, they changed its name, model, thank you. Which is a true representation of the Volume 2 procedures in the Highway Safety Manual. I mentioned earlier the CMF clearinghouse at the bottom. If you're doing a safety analysis, there's also an AASHTO-ware product that's called Safety Analyst that has a general representation of the SPF approach, doesn't use CMFs but use the SPFs. In addition to that, if you were to go to the AASHTO's website, their website is highwaysafetymanual.org. And down here in the lower right-hand corner, you'll see this little gizmo that says spreadsheets. And if you were to click on that, there's a zip file you can download, and it has spreadsheets for all the safety performance functions in the Highway Safety Manual. And all the safety performance functions have with them companion crash modification factors. And those spreadsheets are self-calculating spreadsheets. So they're the easiest way that we have come up with on trying to help you very quickly for one location do calculations. If you want to do a quarter, IHSDM is the way to go, without any question. If you want to do just one site, the spreadsheet might be a faster way to do it. They'll give you the same answers, by the way. So this is just an example of how you might evaluate options using the Highway Safety Manual. Let's say, for example, you have an intersection, and your approach could be that you have a shared left and through and a shared right and through, and you're trying to decide would it be worth the crash reduction to add a left turn, but I would still have to narrow my lanes a little bit. You could certainly use the Highway Safety Manual to do that. You have to do a calculation for the effect on segment, which is going to capture things like lane widths. You have to do one for the effect on intersection, which is going to capture things like turn lanes, and then you just add the two together. So you have to remember to do both of those and add them together. That's probably one of the more common errors I see. This is one of the spreadsheets, and really on this one all you do is you just input your geometric characteristics in the very top form, and then you can scroll down and play with all the numbers, play with options if you want. On this particular one, it would then give you these solutions, and so you could just add the intersection and segment crashes, and it would tell you the total predicted crashes for total crashes, and then also did it for FI crashes. And then you would want to try and make sure that you know which one is the more important one there. If you have, for example, two that tied for total crashes, but one of them was more clearly better performing with the FI, that's of course the direction you would want to go. So some other resources that are available. In addition to the AASHTO site, there are some NHI courses that have been developed which are really great. There's an overview course. The one that I like the best, it's the most recent one, so that's probably why I like it the best, is the Crash Modification Factors Workshop. They've given a pilot of it. I think they're now ready to roll it out and start giving it widely. And it's a really great course. And the gentleman who at least gave the pilot, Frank Gross, did a fabulous job with it. You can also get other information from the Clearinghouse. They actually have several resources that they've developed for the Clearinghouse. ITE recently developed a tool that, or a document that's called the Integration of Safety in the Project Development Process and Beyond a Context-Sensitive Approach. That example I showed you a minute ago is actually in a draft format for a product that FHWA is in the process of finalizing, which is also how you can incorporate Highway Safety Manual in the project development process. But the one thing I want to leave you with today is that the procedures are based on computational information. They are rigorous in their development, but they've been put into a format, particularly with the companion tools, that can be used by anyone who has a basic understanding of what these roads need to look like and what some of the options are. And so safety is not meant to be just for experts. These tools, the Highway Safety Manual, is meant to be for all of our profession. And the sooner we can give an opportunity to have people have that exposure, the happier we'll be. So what's next? As I mentioned earlier, the first edition was published in 2010. We're still developing resources and tools. There's several projects actively developing these. The next edition is expected to be somewhere around 2019, which probably means 2020. The production contract for that next edition was actually signed just last week. So now we're actually legally allowed to say who the contractor is, and it's a team of Kittleson Associates and TTI. So we are supposed to get to work on that right away, so it'll take us a short 4 years. So I'm happy to answer any questions. Thank you for your attendance. It's always tough being the last one, and I appreciate you coming.